Page 381, lesson 7.1 is on understanding the Pythagorean theorem. So a question here is, how does the Pythagorean theorem relate the side lengths of a right triangle? So we're going to go ahead on to page 382 to see how this works. This first thing I have on this slide actually goes back a little bit. Used to be iStep, now called iLearn. They had a reference sheet with a bunch of different formulas that they gave you. And it's changed now. They don't give you a reference sheet. What they do instead, though, actually, Pythagorean theorem, that formula will be given to you if it's on a problem that you're going to need to use it on the iLearn. So it's actually a bonus for you in a way, because on iLearn, if you need the Pythagorean theorem, they're going to say, hey, here's this Pythagorean theorem formula that you're going to need to use on this problem, instead of a whole sheet that you're looking at as you go through the test and just deciding when do I need it or when do I not need it. Okay, so that Pythagorean theorem will be given to you on the iLearn test. So if you look at example 1, we have a right triangle with side lengths A, B, and C. Construct a logical argument to show a squared plus b squared equals c squared. Okay, so on this triangle, we have the hypotenuse. Sorry, my line's a little high on that. It almost looks like I'm crossing it out, but hypotenuse is the longest side of the right triangle, and then the other two sides of the triangle are called the legs of the triangle. Those are the two shorter sides of the right triangle. So we're not going to go through the whole process here. You can look at it if you'd like, but anyway, they worked this out and they figured out that on a right triangle, if A and B are the legs of the triangle and C is the hypotenuse, they figured out that A squared plus B squared equals C squared. So the reason that's helpful for us is because then if you have a right triangle, if you know two of the sides, you can figure out the third side. This has a lot of practical applications. For example, if we were building a house, we would want, normally I would say we would want the room to be kind of a rectangle, and we would have 90-degree angles where the walls meet. If we split the room in half, then that would be a right triangle. So actually what they can do when they build houses, they could measure how long this wall is. They can measure how long this wall is. And they can measure the diagonal. And that would tell them if they have an exact 90-degree angle where those two walls meet. Okay? Because what happens is if it's off a little bit, then this angle's different, then that's going to change the length of this diagonal also. And then we can say, oh wait, it doesn't work. Okay, we'll get into that later in the chapter, but that's just one practical application for how we can use the Pythagorean theorem. So on the try it, they're giving us some information about a triangle. And what I'm going to do is I'm going to draw a triangle so we can kind of visualize what's happening here. So it says it's a right triangle. It has side lengths 15, 25, and 20. How can you use the Pythagorean theorem to write an equation that describes how the side lengths are related? Okay, so earlier we talked about the legs of the triangle and the hypotenuse. And that's what I'm going to think about when I go to put the numbers on my drawing. So we know we talked about the hypotenuse is the longest side. So with sides of 15, 25, and 20, the longest side would be the 25 centimeters. So that would be our hypotenuse. Okay, the reason why the hypotenuse is the longest side, it's across from the 90-degree angle. We've got 180 degrees total in a triangle. So if you have 90 degrees and there's 180 total, you've only got 90 degrees left for the other two angles. And what happens is that 25 centimeters length, that length is determined by how big this angle is over here. So that is going to be the biggest angle in the triangle, and then that means that the side across from it is going to be the biggest side in the triangle. So one way of doing this, one way you could think about that is you could make that right angle into an arrow that points towards your hypotenuse. The 15 centimeters and the 20 centimeters would be the other two sides then. So the legs of the triangle are A and B, and it doesn't really matter which one you put for what. What does matter is what you put for the hypotenuse. The hypotenuse is the longest side, and it has to go in place of C in our equation. So if our equation is a squared plus b squared equals c squared, the 25, since it's our hypotenuse, has to go in place of the c. And then the 15 and the 20 go in place of a and b. If you put, instead of 15 squared plus 20 squared, if you did 20 squared plus 15 squared, that's fine. What we've got to make sure of, though, that 25, since it's the longest side, it's the hypotenuse, has to be over here in place of C. Also, you make sure you remember that all of these are squared. So what we could do at that point, we could actually work this out and verify that this works. So 15 squared, we could do, it's 15 times 15. Also, on your calculator, there's an x squared button. There's an x squared button just to the left of the 7. So you could type in 15 and then the x squared button, and it would show 15 squared on your calculator, and that's 225. We could work it out by hand. It just makes it go quicker with the calculator is all. 20 squared would be 20 times 20, which is 400. And then 25 squared, 25 times 25 is 625. And we could verify this then. 225 plus 400 is 625. So since those are equal, that shows me that this is the right triangle. We'll talk about in one of the sections later in this chapter, but Pythagorean theorem only works for right triangles. These are only equal to each other if we have a right triangle. On example 2, rather than just giving us all 3 side lengths and saying, that we can show it is a right triangle, this one they're telling us it's a right triangle, and they're asking us to find the missing side length. So a squared plus b squared equals c squared. If you look at the picture, you can see that the hypotenuse is the side that we don't know. Okay, like I said, you could, if you want, you can make that right angle into an arrow that points to the hypotenuse, and you can see we don't know what the length of the hypotenuse is. What that means for us is in our formula, our equation, a squared plus b squared equals c squared, we're just going to bring the c squared down since we don't know what the hypotenuse is. And then the other parts, we know the 2 legs of the triangle. The 2 legs of the triangle are 8 and 15. So that's how we've got 8 squared plus 15 squared equals c squared. Once we've got those substituted in, just like we did on the last problem, we're going to go ahead and square the things that we know. So 8 squared, 8 times 8 is 64. 15 squared, 15 times 15 is 225. We're going to be trying to figure out what c is equal to. So what we can do next is we know since 64 and 225 are on the same side of the equation, we can combine those. Those are like terms that we can combine. We can just add those numbers together, which is 289. So 289 is equal to c squared. We're not trying to find out what c squared is, we're trying to figure out what c is equal to. So we've talked about opposite operations before. In an equation, if we're trying to solve for a variable and they're adding next to the variable, we subtract. If they're subtracting next to the variable, we add. If they're multiplying next to the variable, we divide. If they're dividing next to the variable, we multiply. In this case, the variable is being squared. To get rid of that, we have to take the square root. The square root is the opposite operation of them squaring the c. So in order to do that, we have to take the square root on both sides of the equation. So we take the square root of c squared. We also take the square root of 289. So when you take the square root of c squared, the square root and the squared cancel out. And that's how we've just got a c here. The square root of 289, we've talked about square roots before. It's what number times itself equals that number. So we could guess numbers and we could say, well, 10 times 10 is 100, that's too small. 20 times 20 is 400, that's too big. So it's in between 10 and 20. And then we could keep guessing numbers until we figure this number out. These are not always going to necessarily come out evenly all the time. So for that reason, and just for speed of us working through the problems, we can also do this on our calculator. So on your calculator, to take the square root, you're going to want to hit the second button, and then the x squared button. Right above the x squared, in the same color as your second button maybe, there's the secondary function, which is the square root. So you should see a little square root symbol above that button. So when you do second and then the x squared button, you should see square root show up on your calculator. And then you type in 289. So it looks something like this, square root of 289. That first parenthesis is already going to be there. The second parenthesis at the end, you can just add that on yourself. Technically, if you don't add it, since that's the only thing we're doing here, if you don't put the parenthesis, it's not going to make a difference on this problem. There will be some problems where it will make a difference, but not with what we're doing right now. So when you take the square root of 289, you should get 17. And so that means that C is equal to 17. And then a couple things we can do then. That means what we're saying is that our hypotenuse is 17 centimeters. So 17 centimeters, what you want to think about then is that we said the hypotenuse should be the longest side. So we want to make sure, is 17 the longest side? We had 8, we have 15, we have 17. Yes, that is the longest side then, so that's good. The other thing you can do to check this is your hypotenuse is the longest side, but it's going to be less than if you add the two legs together. So think about, for example, if you were trying to walk to something. If I'm at one of these dots trying to get to the other dot, the quickest way for me to get there is going to be just to walk in a straight line. Okay? The shortest distance between 2 points is a straight line, they say. That'd be the quickest way of getting there. Okay? I could go over here and over here, but that would be a longer path. So just like that, when we're looking at the sides on this triangle, we had, I kind of flipped this around, but this was 17, 15, and 8. Okay, that 17, if I'm going from one point to the other, that's going to be the shortest distance. So 17 should be less than if I add the 15 and the 8 together. So 15 plus 8 is 23, and that should be bigger than 17 because that's a longer distance for me to walk if I'm going in between these 2 points. Okay, so those are two things you can look for to help verify if your answer is correct. One is that your hypotenuse should be the longest side. The other thing is your hypotenuse should be less than if you add the two legs together. So this gives you a little bit of an idea on how to work with the Pythagorean theorem. We will continue in the next video. Have a good day.